Hello sir, my name is Ram Delmore and I want to make a video on the topic of differential equation. First of all, let me define what is the differential equation. Differential equation is an equation which contain independent variable, dependent variable and the derivative of the dependent variable with respect to the independent variables. And when we say this type of equation, we would say that this is a differential equation. There are two types of differential equation: ordinary differential equation and partial differential equation. But in our syllabus there are only one thing, ordinary differential equation, so we will discuss about that only. Let's go ahead, and there is another important concept which is order of the differential equation. Order is the highest order derivative which is present in that differential equation. For example, I am going to say that dy by dx plus py is equal to q. So here the order is equal to 1 because the dy by dx is the 1 times derivative of the y with respect to x. If I take the example d square y upon dx square plus p dy by dx plus q is equal to some constant, here the order will be 2 because double the derivative is present in this differential equation. So in this way we have to proceed and we have to find out that what is the maximum order derivative present, what is the highest order derivative present in that particular differential equation. Let's go ahead and discuss the concept of the degree. If we know the order, then it is not so much difficult for us to find out the degree. Degree is the power which is present in the highest order derivative. We have to remember that this power must be free from the fraction and from the radicals. For example, I am going to say that dy by dx plus py is equal to q. Here order is equal to 1, so the power in dy by dx is equal to 1. So I would say that the degree is equal to 1. It may be possible that I can take an example like dy by dx to the power 1 by 2 is equal to y. So here order is equal to 1, but degree can't be 1 by 2. So we will have to square both sides, and this will become dy by dx is equal to y square, and now degree will be 1. So we have to take care that our differential equation must be free when we are trying to find out the order or degree. At that time we have to arrange our differential equation in such a way that highest order derivative must have the order in form of integer numbers, positive integer numbers, maybe 1 2 3 4 5 like this. So these are some things about the degree. Sometimes they can ask you that sometimes degree is not defined, so we have to remember that whenever dy by dx is there is not polynomial in form of dy by dx or double d square y upon dx square or d cube y upon dx cube and so on. So we have to, when we are solving any differential equation, we have to analyze that that differential equation must be a polynomial in form of dy by dx, maybe double derivative of y, maybe triple derivative of y, and maybe anything else. So we have to remember all these things. For example, someone asking to you that sine double derivative of y with respect to x plus dy by dx is equal to 0, and now I am asking to you that what is the degree of this differential equation. So it is not degree is not defined in this case because this is not a polynomial in dy by dx or double derivative of y or triple derivative of y. If you just try to remove sine from the double derivative of y, this will come in double derivative of y is equal to minus sine inverse dy by dx. Again this will come sine in right side. So at this point this will not be defined. Sometime it may be possible that you will interact with the example like sine dy by dx is equal to x plus y. So here degree will be defined because this can be written in this may be a polynomial of the in form of dy by dx or higher order derivative. You can say dy by dx is equal to sine inverse x plus y. So this is a degree is equal to 1. So degree, in this case degree will be defined. So we have to remember that our differential equation must be a polynomial in form of dy by dx, or double derivative of y, or triple derivative of y with respect to x or any another variable. So then in that case degree will be defined. So these were something about the degree and order of the differential equation. It will be asked in the examination that one equation is given, and they will ask us that what will be the possible differential equation of this equation or line. Then we have to find out. For example, the line is given y is equal to mx plus c, and it is asked that I have to find out the differential equation of this line. So what I have to do, I have to just observe that how many arbitrary constants are there in this equation. There are two arbitrary constants, m and c. So I have to find out the derivative of this line two times with respect to x. So we can get the m in form of double derivative, and something c in form of yx or double derivative. So we have to put the values in the original equation, and we will get the differential equation. So mainly we have to remember that how many arbitrary constants are there. So as much arbitrary constant will be there, we have to find out the derivative of that particular equation, curve or lines as much time. So we have to keep these things in mind. And sometime it may be possible, generally they ask question that any differential equation is given, and they will ask that what will be the solution. Mainly they are asking that this differential equation is representing which type of lines or curve. So at that time we have to solve that differential equation, and there are in our syllabus there are three methods to solve differential equation. First one is the variable separation, and second one is the homogeneous differential equation, and third one is the linear differential equation. So we have to remember all these things in our mind, and we can solve the problems one by one. In variable separation, we have to carry all the terms containing y or higher power of y inside of the dy, and all the terms of x, all the function of x will come in the side of dx, and then we have to integrate, and we will get the answer. In homogeneous differential equation, we have to replace y by x or x by y with some function, and then we have to put these values there, and we can find out and then we can solve. In linear differential equation, there is one particular form, that dy by dx plus py is equal to q. Py and q is the function of x, and then we have to proceed. Here we will have to find out the integral factor, which is equal to e to the power p dx, and we put this value in the equation. Y is equal to integral factor y multiplied by integral factor is equal to integration of q integral factor dx plus c. We will solve these questions, and we will get the answer. Sometime may be possible that our question will be in form of dx by dy